In this session, we are going to solve a few interesting questions based on similarity, and we are going to conclude on some interesting properties that are related to triangles. So in this session, the discussion is going to center around a typical setup, which is a bigger triangle, which is triangle ABC in this case. The triangle ABC is a right angle triangle at A. Right, so angle A, the complete angle A is 90 degrees, and I have drawn an altitude AD which is perpendicular to the hypotenuse BC. So this is like a right angle triangle within a right angle triangle. So I can consider that I have a right angle triangle ADC which is embedded within the complete right angle triangle BAC, right? So I can consider the following. So given in triangle ABC, I have angle A equal to 90, that is shown in the diagram here, and the side AD is perpendicular to BC, which means angle ADC is also 90 degree. We have to prove that angle ABD, that is this particular angle ABD, that's this angle, is similar to triangle CAD, that is this particular triangle, right? So we basically have to show that these two triangles are similar to each other. Now, if I have to show that the two triangles are similar to each other, basically there are no side lengths that are given. So I will have to rely mostly on angles. So now let's see if I can figure out some angles in this particular triangle. So let's start with the angle hunting process. Let's assume that angle B is X. Okay. So let angle ABD be equal to X. Now I know that in triangle ABD, so if I consider triangle ABD is the blue colored triangle which is colored over here, and in triangle ABD I can say that X plus, of course, angle D is also right angle, right? So X plus 90 plus angle BAD is equal to 180 degree. And why is this so? This is because this is the angle sum property of a triangle, right? Therefore, I can say that if this is angle X, then we can compute angle BAD. Angle BAD therefore will be 180 minus 90 minus X, which is basically 90 minus X. Therefore, I can say that angle BAD, this particular angle, is 90 minus X, correct? And now I can figure out angle DAC. So I can say that angle DAC is this portion, right? This particular portion. This is angle DAC. I know that angle DAC can be written as 90 minus angle BAD, isn't it? Because the whole angle A is 90, of which this part is 90 minus X. Therefore, angle DAC can be found out as 90 minus angle BAD, which is 90 minus of 90 minus X. Opening up the brackets, I get 90 minus 90 plus X. 90 minus 90 cancels, and therefore angle DAC is equal to X. So this particular angle is X, this angle is 90, and therefore again using similar logic, I can find angle C. Angle C is going to be 90 minus X, right? Therefore, now if you notice these two triangles have the same set of angles. You will notice that they have angle X, then they have 90 minus X, and then they have 90. So I can say consider these two triangles for similarity, right? So we can now consider triangles for similarity. Let me just shift this here. Yeah. So now let's say consider triangle ABD and triangle CAD for similarity. And ABD is the blue triangle and CAD is the green triangle. So we get angle ADB is equal to angle ADC. This is because both are equal to 90 degrees, right? Both these angles are equal to 90 degrees. And we also have angle DAC. Angle DAC is basically X and angle ABD is also X. This is also X. And therefore we can say that triangle ABD is going to be similar to triangle. So now let's see the corresponding points. D and D correspond to each other. So D is the last vertex. So here also D is the last vertex. Then B in the blue triangle, that is B in triangle ABD is X, and that corresponds to the point A. So B will correspond to point A, and then you have C, which is 90 minus X. So here angle A is 90 minus X, angle C is 90 minus X, and therefore this is true by the AA test of similarity, correct? So we have proved the first part. Now we have to prove AD square is equal to BD times DC. So because these two triangles are similar, let us use CSST now. So by CSST I can say that AB divided by CA is equal to BD divided by AD, which is equal to AD divided by CD, right? This is corresponding sides of similar triangles. Now I want AD square, which means I should pick the second and third ratio. Cross multiplying, we get AD square equals BD times CD, right? Therefore, we have proved the second part also. What I want to summarize is, if you see a right angle triangle within a right angle triangle, we should notice that angle X is equal to this angle X. Then another thing that you should quickly notice is this angle is going to be equal to this angle, and then you have 90 and 90, right? So these two triangles are similar to each other, and then CSST gives you this desired result. This particular result is known as the theorem on geometric mean, because in case of continued proportion, you will learn that if B square is equal to AC, then A, B, C are said to be in continued proportion, and continued proportion basically is a geometric progression, right? And where B is called the geometric mean. So here AD square is equal to BD into DC correlates with B square equal to AC, which means that B is the geometric mean, and therefore AD is the geometric mean of BD and DC. So AD square is the altitude of this triangle. So let's quickly highlight what we have concluded. This is the altitude of the given triangle. So this altitude AD square is equal to BD multiplied by DC. Now this is true only when you have a right angle triangle within a right angle triangle, and so in such cases, if at all you see that you have a right angle triangle within a right angle triangle, you can always use this particular idea. So pausing for a few seconds for you to notice this idea, and then we will continue with the next problem. Moving on to the next question. So let's consider this particular question now. We again have a right angle triangle at A and we have AD perpendicular to BC. So this is very much similar to the previous question. The given diagram is very much similar. We now have to prove that triangle ADC is similar to triangle BAC, that is the whole triangle. Yeah. So let's do one thing. Let us quickly mark the angles. As we worked out in the previous problem, let's assume that this angle is X. So if this angle is X, we saw that the previous angle, the angle BAC, this particular angle, the third angle, can be given as 90 minus X. So this is 90 minus X, right? And this angle is also 90, right? And if this angle is 90, the complete angle A is 90. So we saw that this particular angle, the angle at A, the remaining part of A, was also X, right? And if this part was X and this is 90, then we saw that this particular 90 is this particular angle is 90 minus X. So we had this particular situation in the previous question. So I have just marked it over here as well, right? Let me just quickly mark these angles. So now that we have worked out all the angles, let me now draw the two triangles separately. So we have triangle ADC and triangle BAC. Let us draw these two triangles separately. So I have drawn these two triangles separately over here, keeping the same inclination. So I know that angle D is 90 and over here angle A is also 90. These two angles are equal. The angle C is 90 minus X in this triangle, and here also the angle C is 90 minus X. And angle A here is X. If you notice, angle CAD is X and so is angle B. Angle B is also X. So now you will notice that these two triangles have three similar angles, right? And therefore they are going to be similar by the AA test. So I can say consider triangles ADC and BAC for similarity. Let us now mark the angles that are equal. So angle ADC is equal to angle BAC, which is equal to 90 degrees. That is because this is given in the question. And also angle DCA is equal to angle BCA, which is equal to 90 minus X, right? And this is by our conclusion, right? So of course you will have to write this, you'll have to write the derivation of all the angles as we wrote the last time. You'll have to write it here as well. And therefore I can say triangle ADC is similar to triangle. Let us find that now. D is 90 and A is 90. So D will correspond to A and C is the common angle. So C should be the last letter and then I have B over here, right? So this is by the AA test. And therefore, because these two triangles are similar, I can say that, so I have proved the first part. Now by CSST, I can say AD divided by BA, AD divided by BA equals DC divided by AC, which is equal to AC divided by BC, right? This is corresponding sides of similar triangles. And now if you notice, I need AC square. So if I want AC square, let me pick the second and the third ratio and cross multiply. So on cross multiplication, what I will get is AC multiplied by AC becomes AC square. So AC square equals DC multiplied by BC is as follows. So that's DC into BC. So this is precisely what I had to prove in the second part. So again, let me show you what is shown in this question. AC square, that is this particular side square, AC square is equal to DC multiplied by BC, right? This is what we have proved in this particular question. So again, I would like to pause for a minute or so for you to grasp these angles. These angles are really interesting and important as well. So if you can understand the placement of these angles, then it gets really easy to solve problems of similarity related to right angle triangles within a right angle triangle. Okay, so let me pause for a minute before we move on to the next question. Okay, moving on to the next question. Let us consider this question. In triangle BAC, so again we are given a right angle triangle. Angle A is 90, AD is perpendicular to BC. So again this is a right angle triangle within a right angle triangle. We now have to prove that triangle ABD is similar to triangle CBA. So in the earlier question we had taken the triangle ADC. Now we have to take triangle ABD. But before we take these triangles for similarity, let us quickly fill our angles. So let this angle B be X. If angle B is X and angle D is 90, then this particular part of A, right, this part of angle A is going to be 90 minus X, correct? So this part is 90 minus X. And now let's take up this particular part. So this particular part would be 90 minus, so this particular part would be 90 minus of 90 minus X, which is 90 minus 90 plus X, right? So 90 minus 90 plus X, where 90 cancels and X is therefore left. So if this part is X, then this particular part, if you consider triangle ADC, this particular part is going to be 90 minus X, right? And therefore again we have a few angles equal to each other. Let us quickly mark all the corresponding angles equal. And now I have to focus my attention on triangle ABD and triangle CBA. So let's go ahead and draw these two triangles separately and also have their angles marked. So I have drawn the two triangles separately. I have also marked all the angles within these two triangles, right? Therefore, I can say that consider triangle ABD and triangle CBA for similarity. And we now know that angle ABD is equal to angle ABC, which is equal to X, right? And also angle ADB is equal to angle CAB, because that equals 90 degree, that is given in the question. Now by the way, angle ABD and angle ABC, it can also be marked as common angle, right? Because this particular angle is common to both the triangles. You can also mark it as common angles, and therefore triangle ABD is going to be similar to, now let us notice the corresponding vertices. D and A are corresponding vertices, so D will correspond to A. B is X, and so B is X over here also, so this is B and this is C. This is by the AA test, right? And therefore I can say that AB divided by CB is equal to BD divided by BA, which is equal to AD divided by CA, and this is because of corresponding sides of similar triangles. Now I have proved the first part. Now for the second part I want AB square. So what I will do is I will take these two ratios and cross multiply. So when I cross multiply, I get AB square is equal to BD into BC, and therefore this is proved. So let me mark again what is equal over here. AB square. So this particular part, AB square, is equal to BD multiplied by BC, right? This is what we are saying in this particular question. Again, this particular property is true only when you have a right angle triangle within a right angle triangle, and this is the result that we obtain. So again, let me pause for a minute before I continue with my next question. Moving on to the next question. Let us consider this question. In this diagram, we have to prove that angle EFD is similar to triangle GHD, right? So let's do one thing. Let us draw these two triangles separately so that we can view anything that's equal in a better way. So let me draw these two triangles separately here. So I have drawn these two triangles separately here, right? I have drawn triangle GHD and EFD. I notice that angle H and angle F are both 90 degrees, and also you will notice that angle D is the common angle in both the triangles, right? Because the same angle is being counted in both the triangles. So I can easily prove this using the AA test. So let me write the proof. We can say that consider for similarity, triangle GHD and triangle FED, right? And now let us mark the parts which are equal. So angle GHD is equal to angle EFD, which is equal to 90 degrees because this is given in the question. And we also have angle GDH equal to angle FDE because the angle D is common angle in both the triangles, right? So this is the common angle. And therefore, I can say that triangle GHD is similar to triangle. Let us see the corresponding parts. So H corresponds to F. H is the second letter, so F is the second letter. D corresponds to D, so this is D, and the third vertex is E, right? So therefore, these two triangles are similar by the AA test of similarity. And now let us mark the parts which are equal. So DH is 8. It's given that DH equals 8. So the first part is proven. Now we are trying to prove to find the second part, which is we have to find DG and DE. So let's mark the parts which are given. DH equals 8, then DF equals 12. That is also given to me. Then DG is 3x minus 1. So this is 3x minus 1. And DE is 4x plus 2. So this is 4x plus 2, right? So if we want to find DG, by the way, if you want to find DG, which is highlighted by this particular side, right? This is DG. If you want to find DG and DE, both are dependent on the value of x, right? So I will first have to find the value of x, and only then I can calculate the values of DG and DE. So using CSST, let me write the ratios which are equal to each other. By CSST, I can say, so by CSST, I know that GH, by the way, GH is not known. So let us drop that, or let us write it. Say GH by EF is equal to HD upon FD, which is equal to GD upon ED, right? So let us write the parts which are given. It is given that DH is equal to 8. So 8 upon FD is 12. So 8 upon 12 is equal to GD. GD is 3x minus 1 divided by DE. DE is 4x plus 2. So now cross multiplying this, you will get a simple linear equation. So let's cross multiply. So 8 times 4x plus 2 is equal to 12 times 3x minus 1, which means 32x plus 16 is equal to 36x minus 12, which means negative 4x is equal to negative 28, or x is equal to 7. So if x is equal to 7, now I can calculate this side. This side DG is given as 3x minus 1, which is 3 times 7 minus 1, which is 20 units. So the side DG is given as 20 units, and DE will be given by 4x plus 2, that is 4 times 7 plus 2, which is 30 units, right? So the side DE is given by 30 units. So what we did here was, once we proved that the triangles are similar, we use the concept of CSST to frame the ratio of the sides, and then we substituted what we knew and what we wanted, and cross multiplying we got a linear equation, and we found the value for x. And once you have the value for x, then you can easily find DG and DE. Okay. So again, pausing for a minute before we continue with our next question. Okay, moving on to the next question. Okay, consider this question now. In this figure, it is given that AB is perpendicular to BC. So there's a 90 degree given here. Let's mark it quickly. There's a 90 degree angle given here, and DE is also perpendicular to BC. And the measurement of these sides are given. AB is 9. So let us write down the measurements. AB is 9 centimeter. Then DE is 3 centimeters. And the length of AC is given as 24 centimeters. So this whole length AC is given as 24 centimeters. We have to find the length of AD, right? So what I can now do is I can think of which two triangles can I pick for similarity. It looks like, because angle B and angle E are both equal to 90 degrees, I can say that AB and DE are parallel to each other, right? So I can say angle ABC is equal to angle DEC, which is equal to 90 degrees. And because these two angles are equal, I can say that the line AB is parallel to DE. Now, the two triangles that I can consider for similarity are triangle ABC and triangle DEC. So let us draw these two triangles separately, and then we can see if some parts of these angles are equal. So now if you notice these two triangles, angle E and angle B are both equal to 90. And you will notice that angle C is the same angle in both the triangles, isn't it? That means I can claim that angle C is the common angle. So what I can now say is, I can say that these two triangles are similar by the AA test. So let us quickly write the proof. I can say consider triangle ABC and triangle DEC for similarity. Let us write the parts which are equal. I know that angle ABC is equal to angle DEC, which is equal to 90 degrees, right? Because that is given to me in the question. And I can say angle ACB is equal to angle DCE because this is the common angle, right? So both these angles are equal, and therefore I can say that triangle ABC is similar to triangle DEC because of the AA test. And because of CSST, so by CSST, I can therefore say that AB divided by DE is equal to BC divided by EC, which is equal to AC divided by DC. Now let's mark those parts which are equal to each other. So AB is 9 and DE is 3, which is equal to BC. By the way, we don't care about BC and EC, so let's drop that ratio. We do have AC is 24 and therefore I can find DC. So from this, I will conclude that DC can be found out as 24 into 3 by 9, which is 8 centimeter, right? So I can say that this length, this particular length, DC is 8 centimeters. So this length is 8 centimeters, which means the length AD is AC minus DC. AC is 24 minus DC is 8. So 24 minus 8 is 16 centimeters. And this is how I calculated the length of AD. So first I proved that the two triangles are similar. You must have noticed that I never used the conclusion that AB and DE are parallel. But I could have, instead of using the common angle C, I could have also said that because AB and DE are parallel, these two angles are equal by the corresponding angles test, right? But I never used it, so I used the idea of common angle. But if somebody wants, they can definitely use angle A equal to angle D because of corresponding angles, and then again AA test holds true. So I first showed that ABC and DEC were similar triangles, and then by CSST I was able to find the length of DC first, and after I found the length of DC, I found the length of AD, right? So this is how I went about this particular question. Let me again pause for a minute so that you can take a look at the solution, and then we will continue. Moving on to the next question. So in this question, it is given that angle QPS. So let us quickly mark the angles. It is given that angle QPS is equal to angle RPT. Let us mark it. And it is also given that angle PRQ, that's this angle, is equal to angle PTS, that's this angle. Now we have to prove that triangle PQR is similar to triangle PST. So let's do one thing. Let us again draw these two triangles separately so that we can easily mark the parts which are equal. So I have drawn these two triangles separately. Let us mark the parts which are equal. So it's given that this angle R, the angle R here is equal to angle T here, right? These two angles are given as equal. So let's quickly mark them. But no other part is given as equal, right? So how can I find the equal part? Now what I can do is, if you notice carefully, angle QPR is nothing but, so let's note that down. Angle QPR is nothing but angle QPS plus angle SPR, right? So angle QPR is the addition of angle QPS and angle SPR, and at the same time angle SPT is also equal to angle SPR plus angle RPT. Now you will notice that these two measures, angle QPS, angle SPR is common in both the equations, if you notice, right? So these two are equal to each other. Let's mark them quickly. So these two angles are actually equal to each other. And similarly, angle QPS and angle RPT are also given as equal to each other, because that equality has already been mentioned in the question over here, right? So these two parts are equal and angle SPR are equal. Therefore, I can say that from this I can conclude that angle QPR is equal to angle SPT. So the reason would be, as angle QPS is equal to angle RPT, and this is given in the question. So essentially what I did was, I took QPS and I added the common angle, right? Similarly, I took angle TPR and I added the common angle, and suddenly I got angle QPR is equal to angle SPT. So now these two angles are also equal. So because these two angles are now equal, I can definitely use the AA test of similarity, right? So I can say consider triangle PQR and triangle PST for similarity, and let us now note the parts which are equal to each other. So angle QPR is equal to angle SPT because this is from 1, so I can mark this as my result 1. And also angle PRQ is equal to angle PTS because this is given to me in the question. Therefore, triangle PQR is going to be similar to, let's check, vertex R maps with vertex T. So R is the third vertex and T is the third vertex, and P matches with P, so P matches with P here, and then I have PST. This is because of the AA test of similarity, right? And therefore by CSST I can say that PQ divided by PS will be equal to PR divided by PT, which is equal to QR divided by ST. This is because of CSST. Now we need to find QR is to PR. So let us try to find the ratio which will help us. I think this particular ratio will help us, because if I shift the PR to the denominator, I will get QR by PR. It's given that PT is to ST is 3 is to 4. So let's do one thing. Let us take this particular ratio, right? So we have PR upon PT equals QR upon ST. By alternando, I will get PR, or rather, let me change this. So using alternando, I am going to get ST upon PT. So shifting these two, ST goes to the numerator, PR goes to the denominator. So ST upon PT becomes QR upon PR. And it's given that PT is to ST is 3:4, right? This is given to me. So PT is to ST is 3:4, which means if I take a reciprocal on both sides, I will get ST is to PT. I have taken the reciprocal, will be equal to 4:3. And therefore, this is going to be 4 upon 3. And therefore, QR upon PR is going to be 4:3. So this is how I can find the ratio of QR to PR, and the concepts used in this question were, first of all, angles were given as equal. Then I added a common angle to both the angles, right? This particular angle was the common angle. This was added to both the angles, and using AA test I proved similarity. And after proving similarity, I used CSST. And then using alternando, I got the ratio that I wanted, right? So let me again pause for a minute before I move on to the next question. Moving on to the next question. In this particular figure, it is given that angle QPS is equal to 90 degrees. So this particular angle is 90. And it is also given that PR is perpendicular to QS. So this is also 90 degree angle. QR is 3.5 centimeters. So QR is 3.5 and QS is given as 8 centimeters, right? This whole length is given as 8 centimeters. We have to find the length of PS. Okay. So we have to find the length of PS. If I want to find the length of PS, if you remember, this is a typical question where you have a right angle triangle within a right angle triangle. If I want to find the length of PS, what I will do is, I will take the complete triangle and triangle PRS for similarity. So let's consider these two triangles for similarity. Yes, so I have drawn these two triangles separately. Now let us consider them for similarity. So consider triangle PQ, triangle PRS and triangle PQS for similarity. So what we get is angle PRS is equal to angle QPS. This is equal to 90 degree. This is given to me in the question. And angle PSR is equal to angle PSQ. That's because this is the common angle, right? And hence I can say that these two triangles are similar by the AA test. So triangle PRS is going to be similar to, so R corresponds to P. So R corresponds to P, S corresponds to S. And therefore we have QPS. This is by the AA test of similarity. So now we can write the corresponding side. So PR divided by QP is equal to RS divided by PS, which is equal to PS divided by QS. This is because of corresponding sides of similar triangles. Now let us mark the parts which are equal. So QR is not is known in this question, right? But I don't see it anywhere here. Let's do one thing. Let us mark the sides which are equal here. I can find RS. RS will be 8 minus 3.5, right? So RS will be QS minus QR. That is 8 minus 3.5, which is going to be 4.5. So RS is 4.5 and QS is 8 over here. That's given to me. So I know that RS is 4.5. So let's note that down. RS is 4.5 divided by PS. PS is not known. I have to find it. Is equal to PS divided by QS is 8, right? So what I did was, because this particular part was not relevant, I just took these two ratios and therefore cross multiplying I get PS square is equal to 8 into 4.5, which means PS square is equal to 36 and that implies PS is 6 centimeters. So to find PS, I took the complete triangle, that's PQS, and triangle PRS for similarity, and using CSST I was able to arrive at the desired result. So let me again pause for a minute before I move on to the next question. Okay, moving on to the next question. So consider this diagram. It's given that BD and CE are the medians. So let us shade these lengths. BD is the median and it's also given that CE is the median, right? So it means that E and D are the midpoints, right? So since BD and CE are the medians, I can say that D is the midpoint. D is the midpoint of AC, and I can also say that E is the midpoint of AB, right? So I have the two midpoints. That means these two lengths are equal, and AE is also equal to EB. Now I have to prove that EGD is similar to triangle CGB. So let's quickly shade the triangles. I have to prove EGD, that's this triangle, is similar to triangle BGC, that's this particular triangle. And I have to prove that BC is twice of BG is twice of GD. This is what I have to prove. So now something comes to my mind. In my earlier years, I have learned something known as midpoint theorem. So I know that in triangle ABC, I notice that E and D are the midpoints. So by midpoint theorem, I know that DE is parallel to BC, right? This is known. And I also know that DE is going to be half of BC. So why was this important? This was important because it now gives me a relation between at least two sides of these two triangles. So I can say that BC is twice of DE. So if DE is marked as X, if I mark DE as X, then I can mark BC as 2 times X, right? So let's mark these. If DE is X, then BC is 2 times X. And now I know that these lines are parallel also. So midpoint theorem actually helped me prove that these two lines are parallel. So now I can say that because these two lines are parallel to each other, can I mark some angles as equal? I can definitely do that. I know that angle D in this triangle EGD is going to be equal to angle B in triangle GBC because of alternate interior angles. And I also have vertically opposite angles equal, right? So by AA test, I know that these two triangles are similar to each other. So I think I have figured out the right way to prove similarity. What I will say is, I will say consider triangle EGD and triangle BGC for similarity. Now I know that angle EGD is equal to angle CGB because of vertically opposite angles. And I also know that angle EDG is equal to angle CBG because of alternate interior angles, right? And therefore triangle EGD is going to be similar to triangle. Let's see the corresponding points. G corresponds to G, so that comes as the second vertex. D corresponds to B, so let that be the third vertex. So D corresponds to B, and therefore the third vertex has to be C over here, right? So this is by the AA test. So I think I have shown the first part. Now let's write the ratios of the sides. So we have EG divided by CG is equal to GD divided by GB, which is equal to ED divided by CB, right? Of which I know the lengths ED and BC. So let me substitute these here. So I can say that EG divided by CG is equal to DG divided by BG, which is equal to ED is X and CB is 2X. So X and X cancels from here, right? So the ratio therefore is 1:2. Now what do I have to prove? I have to prove BG and DG, right? So what I will do is I will take these two ratios and cross multiplying I get BG is equal to 2 times DG, right? And this is exactly what I had to prove. And this is by CSST. We should always mention this. And hence we proved this particular problem. Again over here, midpoint theorem came to our rescue because we had two midpoints. So using the midpoint theorem made a lot of sense. And because of the midpoint theorem, I was able to get ED parallel to BC, which helped me prove similarity by the AA test. And then of course, the midpoint theorem told me that the base is twice of ED, and that helped me prove the second part. So this is how we go about this question, and we conclude our session over here today. And I will pause for a minute and then we close the session.